In method 2, we have the following. So I'll bring my benzene ring here. We have the following. We have CH3, C, Cl with the anethylene chloride. So iron has vacant orbitals, indicating that it is electron deficient or it is an electron pair acceptor. Therefore, since this bond is polar, chlorine takes electrons towards itself and then donates them to electron deficient iron. Once it donates there, then this carbon also becomes electron deficient. So we take electrons from benzene and donate them to that electron deficient carbon. As a result, we shall have the following. So we have our ring. We have our ring like that. Then one of the carbons, these two carbons, since they have the same number of hydrogens, it bonds with this carbon. It bonds with that carbon atom, with this carbon atom, which carries oxygen and a methyl group, like that. Now the circle which was showing the localized pi electrons, the localized electrons within the benzene ring is broken. So we shall have a circle of this form with a plus there. Then chlorine, once it donated to this ferric chloride, we form a complex. We form a complex plus FeCl4 with a negative, like that. Then after that, there is a hydrogen here. There is a hydrogen atom. So we expose it and use electrons there to donate to electron deficient carbon. As a result, we are losing a proton. We are losing a hydrogen ion as we form this as our product. Now there are certain things that are going on. There are some, I don't know whether it is tear gas or live bullets, but let us continue. I think today Chagulani is around here. Is in Busiro North and Busiro East. So, and I'm here in Namungona, so I am not far away from Busiro East and Busiro North constituents, but I can hear live bullets and tear gas. So the proton that has been lost, combines with the complex FeCl4. So this donates electrons there. So we have hydrogen chloride plus iron 3 chloride. Therefore, our products in this case, we have hydrogen chloride plus phenyl ketone. That is method 2, quite similar to method 1. Example 2, we have benzene reaction with benzoyl chloride. This compound is known as benzoyl bromide. Still, it is an acyl compound. We have seen that there are two approaches to this reaction, approaches towards writing the mechanism in the first example. Now that you know those approaches, allow me use only one approach. So we have our benzene ring. This is my benzene ring. Benzene. I want to react this benzene with the benzoyl bromide. So I write my benzoyl bromide in this form. Benzoyl bromide, I write it in that form. This benzoyl bromide, it is reacting in presence of iron 3 bromide. Now the Lewis acid catalyst is electron deficient because the central metal atom has vacant electrons, has vacant orbitals. The central metal atom has vacant orbitals which can accept a pair of electrons. So since it is electron deficient, here we have a polar bond. Bromine pulls electrons towards itself and it brings those electrons so that they are donated to the central metal atom. Then this carbon as well becomes electron deficient. In simple terms, this has a partial negative charge, this has a partial positive charge. Then we use one of the 3 bonds to donate electrons to that carbon. As a result, we shall form the following. We have, now here you have to be very careful. We have our benzene ring, we have our ring. This is our ring, like that. This bond was broken, so there is this bond and that bond. Now this carbon bonds with this carbon. It bonds with the carbon atom. Carbon atom which has a double bond with oxygen, but this carbon atom that has a double bond with oxygen also carries a benzene ring. This as well carries a benzene ring, like that, implying that this will be electron deficient. Then bromine with the Lewis acid catalyst, we form, so plus FeBr4 with a negative. Then I expose the hydrogen here. I expose the hydrogen there so that it donates electrons to that electron deficient carbon. Then we lose a proton. We lose a proton minus hydrogen ion, as we form our product, like that. So we have the double bond is restored, so we have C double bond with oxygen. This was restored, double bond with oxygen, then this carries a benzene ring. This carries a benzene ring, like that. Then the hydrogen ion plus FeBr4. So this donates to hydrogen to form hydrogen bromide plus iron 3 bromide. Iron 3 bromide, like that. So you may think that this thing is difficult to name. However, it has one carbon atom and it is a ketone. So its name is, this carbon is 1, meth 1. It has 2 branches. And recall from school we saw that benzene, as I think I also explained it here, benzene as a branch is phenyl. So there are 2 branches. So the name of this is diphenyl methanone, because it is a ketone or an alkanone. So that is why you have diphenyl methanol. Then do not always forget to complete. I don't know whether this space will be enough, but I want to complete the reaction. We have formed hydrogen bromide, then plus diphenyl methanol, which is of this form. The space is enough. That is my product. Those are the two products I have formed.